Hello guys, in this video we will take a look at another type of container that's similar to vector but behaves a bit differently in some of the use cases and aspects. So let's get started. So if you take a look at this particular output over here, what I have done is while providing the input to the vector, I have done two things. One is I have repeated one of the elements. So the fourth element was 22. The fifth element also is 22. That is one aspect. The second thing is that if you look at the uh, order of these elements, they are not sorted. They are not sorted in ascending order. You have 67 first, and then you have 12 coming in, and then 34, and then 22. So they are not like in a particular sorted order in an ascending order or in a descending order. And when we have input the elements in such a fashion to the vector, and when we print the elements of the vector, what we notice is that we had duplicate elements being inserted, and those duplicate elements have been retained, which means you can have duplicate elements inside a vector. The second thing is, even though we have not entered it in some ascending order or a descending order, the order of insertion has been maintained while storing in the particular vector. 67 first, 67, 12, 12, 34, 34, and then 22 two times. So the order in which the input has been entered doesn't matter whether it's ascending order, descending order, or some random way. The order of insertion has been maintained in the vector. That is point number one. Point number two is that the duplicate elements are accepted inside this particular vector. Now, there will be some scenarios where you want to have a type of container where you don't want to have duplicate values. You want to store only the unique values. That's point number one. And also sometimes you want to insert some elements in a random fashion, but when it is stored internally inside that container, it should be sorted in an ascending order, say for example. So in these scenarios, you can use something called as a set instead of a vector. So that's what we're going to see in this particular video. So instead of vector, let us use something called as a set. Okay. So let me tell this is a set here, and set. Um, I think yeah, that should be fine. Um, and instead of the emplace back, we need to use a different function in the case of set, which will be called as insert. Okay. And okay, we can also have this here. Oh, sorry, instead of size, it should be set. And we also need to iterate over this also with the set. So elements of, no, it's not the element of the vector, it's the elements of the set in this particular use case. So this is it. Let me clear the screen. Let me execute now. Um, and okay, so let's say five elements of the set, and what I'll do now is again put elements in a random fashion. 34, 12, 88, and now what I'll do is I'll insert two duplicate values, 44 and 44. Okay, hit enter. There you go. See, the difference over here is that even though you have entered five elements, the size of the set remains to be four. This is the first difference. The reason for that is you cannot have duplicate elements being stored in the set. It only stores the unique elements. So 44 is already repeated, so it's not going to consider this entry. Only these many entries will be considered, and that is why it is 4. And the second thing is that even though you have entered in random fashion, when it is stored inside the set, it is always stored in the ascending sorted order. So this is another importance of the set. So in the scenarios, wherein you want this kind of a functionality, you can use set instead of a vector. That's what I want to convey through this video. That's all. We'll meet in the next video. Thank you.